All right, welcome back everybody. So this session we're going to start talking about data more thoroughly, and we're going to hear from a number of the NCRIS organisations who are represented here from their data leads and hear what's happening within those organisations. And we're going to have an opportunity for a conversation that follows that. So you will all, again, have an opportunity to speak and to let us know what you think our challenges and opportunities and things are in that context of that conversation. But we're going to start the discussion off now with a presentation from Lauren Sullivan, who is with the Academy of Science. And thank you for hosting us today, Lauren. And Lauren's going to talk about the perspectives on data in science from the Australian Academy of Science. Thank you.
Thanks, Tim. Hi, everyone. I'm Lauren. I'm a policy analyst at the Academy of Science. I'll just start with a disclaimer. I am not a data expert, but I am presenting today because in my role at the Academy, I have had the fascinating job of talking to scientists from across all scientific disciplines from all over Australia about data and research infrastructure needs and challenges and turning that into science policy advice. So today I'll be providing an overview of the Academy's work in the data and research infrastructure space, and much of which has been informed by input from people at this conference symposium today. So yesterday we had a range of talks about integration across the spheres, and as Tim highlighted this morning, data seems to be a really key opportunity for impact. So I'm sure much of what I highlight won't be new to you, but I'm hoping to spark some thinking about developments in data, research infrastructure, and ways of collaboration that are needed to achieve our research ambitions and goals of greater integration, and inform some of the discussions on the white paper later today. So Simon provided a really detailed international perspective of what's happening. So I'll zoom in and provide a snapshot of the Australian context in regard to science policy and data. So we're working in an environment where tech developments like AI, big data, digital twins, high-performance computing, and new computational techniques are really evolving how we do science. And many of our major national and international challenges that Simon and Dahlia covered are all underpinned by the ability to access and use data to make decisions. And this is not unique to earth sciences, this is across all different types of science. There's a growing awareness of issues such as open science, how government data can better be shared and collaboration between government departments and within the public service, and also between different levels of government, state, federal, local, and things like Indigenous data sovereignty, which Cassandra covered. We have a data commissioner who oversees the data scheme, which is about sharing government data, including for research purposes, and the National Data Advisory Council advises that commissioner on things like ethics, balancing data availability with privacy protection, trust and transparency, technical best practice, and also industry and international developments. And Australia's chief scientist is on this council. So there are several key policy reviews affecting the research community that have been delivered or are in progress, such as the National Science and Research Priorities, the Universities Accord, and review of the Australian Research Council. And while these are much broader and high level than data, I think it's important to flag them because they provide a perspective on the policy context and framing in which we are operating. And to kind of highlight that there are national level conversations happening that impact the research system and influence our research ambitions, which data is tied to. And I think it provides a sense of the expectations of the relationships between government, research agencies and organisations and us as the research community. One piece of policy that is more specific is the National Research Infrastructure Roadmap, which specifically acknowledges the increasingly data-intensive nature of research and the need to be able to access, use and share data. And it outlines some of the opportunities for improvements in the national research infrastructure system. And it recommended development of a National Digital Research Infrastructure Strategy, the NDRI strategy, and which should address data access and interoperability, data storage, trust and data quality, high-performance computing, software skills, and national integration of infrastructure. So it's no small task. There's lots of threads that kind of run through these data challenges for research. So the Academy has and is engaged in this space, and we work with our fellows and experts to provide advice on the data and infrastructure needs for science. One of the projects that I've been involved in working at the Academy is this report on advancing data-intensive research in Australia. And this was co-chaired by Academy Fellows Professor Michael Barber and Professor Jane Elith, and was funded by the ARC through the Linkage Learned Academy's Special Research Projects scheme. This project involved desk-based research and also national and international consultations with stakeholders in government and the research sector. And it presents some opportunities to advance data-intensive research in Australia by aligning policy, infrastructure, skills and education, and recognising data science as a scientific discipline. A few of the, I guess, key outcomes of this report were broad implementation of fair and care principles, policy and associated practices and protocols need to address data generated by the research community, and also access to data for research purposes. So I'm sure many of you have accessed government data sets, and also people were mentioning yesterday about data sets from the private sector and industry. Australia's research infrastructure will need to prepare for significant trends, such as increasing volumes of data, demand for significant data repositories, and also the evolution of supercomputers. And I'm really interested in hearing the next talk with some of our research infrastructure representatives. There's also a need for training and digital skills development within the research sector, and developing a competency framework for these digital skills. And this is both among researchers, but also having dedicated data experts. Another piece of work that we've been involved with, we worked with the Australian Research Data Commons and the other Australian Learned Academies to identify national strategic data needs for science, technology and engineering, humanities and social sciences. And the idea of this project was also to facilitate coordination between the academies on data infrastructure and policy advocacy and advice. So this was also chaired by Professor Jane Elith and was guided by an expert working group of Academy Fellows, and involved workshops based on scenarios which were developed to prompt discussion on data and data infrastructure capability to meet future research challenges. And I do know some people here who were involved in some of these workshops, so I thank you for your time and input on this. And some of the key findings that emerged from these multidisciplinary workshops included driving greater national coordination and integration, which is the word of this conference, and developing consistent and enforceable data policies and standards to facilitate access, interoperability, responsible use, reuse and sharing, promoting data sharing by recognising data and software sharing in academic success metrics, and investing in the people and infrastructure to manage data and make data fair, because it's no small task to implement these principles. Addressing challenges presented by expanding volumes of data and data-intensive research activities, such as moving, manipulating and analysing large amounts of data, data storage and data retention. And again, that theme of needing to build a skilled research workforce. I'll now mention a couple of projects that are currently in progress. One of them is accessing Australia's research collections. And this is another area that's intertwined with data issues. So the emergence of new technologies impact storage and analysis and digitisation, big data and computing, which are changing how researchers use and access national research collections. Now, collections is very wide-ranging and includes things like geological data and specimens, the collections that are held in libraries, galleries and museums, and even living collections at zoos and botanic gardens. And so we've been engaged by the Department of Education to understand opportunities for a nationally coordinated approach to research collections. And this would improve the description, discoverability and access to collections through standardised metadata and indexing systems, consistent practices for cataloguing collections, and establishing a centralised platform for facilitating the search and location of collections. And in the hope that it will lead to greater interoperability and collaboration across research. And so we've been conducting consultations in collaboration with the Academy of Humanities and Academy of Social Sciences, talking to people from government, research agencies, universities, galleries, libraries, archives and museums to understand the maturity of our research collections and produce a draft scope of what should be considered in a national approach to collections. And we've identified a few areas for improvement in discoverability and accessibility, the need for transparent stewardship and infrastructure requirements, the need for leadership and coordination, and also considering Indigenous data sovereignty. And so maybe you've personally experienced some challenges in accessing research collections, and this project will be open for broader consultation soon, so keep an eye out on the Academy's website if you're interested in finding out more. Another area of our policy work is convening expert roundtables, and we do this to provide science advice on a range of policy-relevant science issues. So coming up in November this year, we will convene a roundtable of Australian scientists and industry leaders to explore future supercomputing needs for the science sector. As science evolves in response to new challenges, the way we use high-performance computing and big data is constantly evolving and growing. So the intent of this roundtable is to provide a multidisciplinary perspective on computing and big data needs to meet our research ambitions. Along with our project work, a core activity of the Academy is to engage with government and Parliament on policy-relevant science issues and to provide authoritative scientific advice to inform policy development. And one way we do this is through providing submissions to inquiries and consultations, such as the National Research Infrastructure Roadmap that I mentioned, and also the Data Availability and Transparency Act. The Academy has also published public position statements on open science, which includes open data, and has published policy articles to generate discussion on open science in Australia. We also have 22 national committees for science that are widely representative of science disciplines, and we have a National Committee for Data in Science, which is chaired by Dr. Adrian Burton. And it works to foster the effective use of data across all science disciplines in Australia and provides a national voice for scientific data and the promotion of Australian science through forums such as UNESCO, the OECD, and as Simon mentioned and is representing the International Science Council's Committee on Data for Science. And so through its work, the National Committee provides the Academy with disciplinary expertise for the submissions that I mentioned, but is also a touch point and coordination for engagement with international unions and the International Science Council. So, bringing this all together, I'm very encouraged by how a lot of the findings of some of our projects have been reinforced, and there seems to be agreement on issues that are emerging from our discussions and lots of positive activities that are happening around data and trying to integrate and improve collaboration. And so I'm hoping I've sparked some thinking in relation to the mission of this symposium to integrate the Earth science spheres and facilitate collaboration. I think things like combining observations and modelling, considering the whole data life cycle, even logistics considerations when collecting data, interoperability and discoverability, and even terminology and shared understanding are things that really resonated with me from yesterday's discussions. And so some of what I think are the key issues and potential opportunities here are that from a national policy perspective, having timely, actionable data is essential to be able to make decisions and inform evidence-based policy making. And it also enables us to answer really exciting new research questions. The way I kind of conceptualise a lot of these issues are through sort of policy and governance, skills and infrastructure. Things like implementing the fair and care principles, storing and sharing big data and really large volumes of data, having shared terminologies and understanding, and preparing skills and our infrastructure for the needs and new developments of the future are really key things that have emerged for me. And we all have roles to play in this. So governments have a leadership role in creating research data policies, strategic planning, coordination and funding for research infrastructure, also supporting education and training, and in facilitating access to government data for research. Research funding bodies have a role in encouraging effective data management resulting from government funding schemes, and also governance of things like research integrity. And then a lot is also driven and led by research communities like us here today. And Simon provided a detailed overview of the international work and considerations for data. And I highlight these roles because these research data challenges are quite layered, from research communities to institutions to governments. And so it's important to consider the audience for the white paper that will be developed out of these discussions as well. So in thinking about the white paper, I'd like to leave you with thinking about what an ideal world for data would look like to achieve the ambitions for Earth system science and the spheres, the 5 spheres, and what do we need to do to get there. This is most of the Academy Secretariat. We are housed in Ian Potter House next door. And if you've got any questions about any of our projects, please shoot us an email. Thanks.
Thank you so much for that presentation, Lauren. Are there any questions from the audience? Nothing. You get away free. No worries. Thank you very much. Okay. So now we're going to move on to the NCRIS capabilities that kind of cut across this space. And we're going to hear from the data leads or nominees from each of those organisations. And do we have slides for this? We do, okay. One slide each. So everybody can come down. We've got 6 of them. They've got 10 minutes each. And I'm going to hold everyone, because I know what this community is like, this group of people. So I'm actually going to be very militant in this session and hold everyone to time.
Thank you. That's great. Yeah.
So, and I think Guru, is Guru up first?
No, I'm up first.
Oh, you're up first. Okay. All right. Well, Rebecca first from AusScope.
Yeah, hi, thank you. So we have a panel discussion afterwards, so we're hoping that we can keep our little talks as short as possible and we can get the most time out of I suppose the collective knowledge of the audience here. So I am representing AusScope, so I'm AusScope's Director of Research Data Systems. As Voon and Sarah ran through yesterday, so a lot of the things that we're involved with include geophysics, geochemistry and geodesy. We have field lab and also kind of like data intensive programs. Interesting about our organisation. There we go. So we have a very small head office. There's only 5 people and it's about 4 FTEs. And we fund projects and programs at a lot of different universities, the CSIRO and the state surveys. So we don't actually hold the data. We use, I suppose, our network. So the data that's kind of coming through universities. The natural home for that data should be at the universities, but a lot of the data that we collect, a general repository at a university isn't appropriate, and I'll touch back on those in a little bit. In terms of, let's see, geophysics, so Voon spoke about this yesterday, so we have a very large repository of seismic data from the Australian region. We've also gone through a project recently that was mentioned yesterday that was funded by the ARDC and a close collaboration between AuScope and NCI and with TERN for pulling together a magnetotellurics data set. So that's a data collection that's now housed at NCI. And one thing that we really focused on, which I think is important, is that that's stepping from the rawest form of the data through processing levels to the final research output. So Nigel's over there. He went through a lot of heartache. They found the data. Hannes, who presented here before, found all the data with Joe, who's I think up there. And Nigel put together all the scripting. So we've got a data collection at NCI that has automated scripting to step through the processing levels. So at any time, researchers can just go there, they can access the data, and by access, we don't necessarily mean just download, so you can access the data and run it on the NCI's compute systems. We also have a lot of geochemistry labs, and recently, over the last couple of years, we've been funding a repository called AusGeoChem. We have a member here today, somewhere, and that's a repository for geochemistry data. So geochemistry data is what we call like the long tail. So there's a huge variety of different types of data that geochemists involve themselves with, and we're trying to work our way through that. So it's also geochemistry is where our link is into Simon Hodgkin's work with World Fair. So One Geochemistry has members from the Australian geochemistry community, but also in Europe and the United States, and they're all working together, trying to understand that geochemistry component of the World Fair group. We provide support for compute and data-intensive geoscience researchers through a partnership with NCI, so we can provide compute as well as data storage in our partnership NCRIS organisations, and we've recently kicked off just in this financial year the AuScope Geoscience Research Data Repository. So Anu spoke yesterday, she's just there. And we're calling that the repository of last resort. So we know where we can put geochemistry data, we know where we can put large-scale data, can be housed at NCI where it's close to compute. But earth science and geoscience, I suppose, has got this long tail of data where we don't really know. Institutions can't look after it appropriately. So we're building a repository. We have a test case with geothermal data, and we've identified a few others. So please approach me if you want to have a chat about that. And we've also just kicked off the Atlas, the modelling Atlas. It's a repository for geodynamics models. So models that Sarah was showing yesterday. So we're looking at housing the output of those data with the code and the input files. The data is going to live at NCI, so people will be able to look at big chunks of data through visualization, but also be able to ideally, restart the models and what have you at a later point. I'm happy to discuss that. In terms of, we run AuScope's data portfolio under 3 different principles, and it's designed, developed, and managed to ensure data and data products align with the FAIR principles. I'm going to do a throw out to CARE as well. We are starting to trying to understand how we can incorporate FAIR principles, CARE principles, sorry. And the Geophysics 2030 project with the magnetotellurics data was really our first exposure, and that was through NCI as well. And we try to operate at international best practice or agreed discipline standards. So we're really trying to encourage our community to look outside of their small community within Australia. And we try to solve our problems collaboratively. And I think that's all. I'm not sure how long that was. Next.
Good morning, guys. I'm Siddhesh Vargara. I'm the program lead for the TERN Data Services Analytical Platform. So we build the infrastructure to manage data collected, collated, published at TERN. So just to provide a scope of what TERN does, TERN is a land-based observatory, NCRIS funded. So we collect data at the multiple scale, predominantly at the landscape, we collect data at the continental scale. These are the remote sensing data products and model derived. We collect data at the regional scale. These are typically the plots spread all across Australia. So currently there are around 850 plots. Predominantly we collect the vegetation and the soil information, including the specimen as well. So the next scale is the ecosystem processes. We call it as more as an intensive monitoring. Highly sensorized, collect data from 10 seconds to half an hour, depending on which sensor we are talking about. So we collect data from the PhenoCam, the flux data set, the acoustic data, and then every 5 years we do the vegetation survey as well of that size. So if you look at all what I just talked about, there is a wide variety of data sets, in situ sensors, remote sensing sensors, human observation, and then some of the ad hoc data set as well. So we need to manage all these things. So we build the infrastructure to do this. So the other thing I forgot to tell is, we publish a fair bit of the state government data sets as well. These are the site survey data sets. So we build a pipeline for most of this. And then to manage this and they harmonize that, so we work fairly on the vocabularies. So for example, if you take the vegetation structural formation, we have a remote sensing product to derive the structural formation. We have the human observation to derive the structural formation. Okay, so when a user comes to our portal, they should know that which one is the human observation and then which one is the remote sensing product. So that's why we use the vocabulary to tag the data. So for example, for every data set, we have tagged the data, so which platform it comes from. For example, if it's remote sensing, even the ecological sites we define as a platform. And then the instrument, if they are used an instrument. And then the observable property, what property is measured, the unit of measurement, and then the person that collects the data, and then the organization that data belongs to. So we have the vocabulary, so all this is a reusable artifacts that can be used by the ecological community. So that is the harmonization point for most of our data sets. So due to the wide variety of data set, we can't just build a one place to, we have a one place to where you can go and discover the data if you want to query, dig deep data at the data level. So we build a multiple dashboards as well. So when we build our infrastructure, our main aim is to make sure that data can be discoverable at the collection level, and then you can visualize the data, and then you have the API access to the data. So most of the data we have collected, the TERN collected data, it fits all this purpose. So we also provide the data submission tool where the one-off data set, somebody wants a DOI, they can come and publish the data. So we provide that as well. So that probably may not have an API access to that one. It's partly because it's not like a time series data. We don't want to spend too much time on making that accessible via the API. But we provide that capability where people can come and submit data, and then they get a DOI, and then we commit that, that data will be the preservation as well. The other thing what we do is, we work, so most of our infrastructure is a cloud native. It runs on the ARDC infrastructure. We work with the other ARDC projects to provide as a software as a service model. So for example, we work with the EcoCommons project to provide the virtual desktop environment TERN build as a software as a service model. So where we manage it, and then it can be accessible by the community. The same thing with the Australian Scalable Drone project. So we provide our data submission tool to submit data to the ASDC, or people from the ASDC can publish data through TERN. And then again, the virtual desktop environment, we provide the GPU node so that people use the WebODM to process the data and make that available. And they can run the AI/ML programs as well. I think with this model, so what's the important thing is that, so we manage the infrastructure. We are not completely rely on the ARDC money for every 6 months or 1 year, but the ARDC projects can leverage our managed infrastructure. So we had a strong governance. So most of our infrastructure, we use a single sign-on where you can use the AAF CI logon. If somebody is from a government department, please use CI logon so that it covers the most of the government. If you select the Microsoft, and then most of the government uses the Microsoft organization, so you can log in through that one. And then the Google as well. So our infrastructure is FAIR compliant. So basically, we use a domain metadata standard, the ISO standard. We have the URI for all the vocabularies. It's discoverable. And then we mint a DOI for most of the data set if it requires as well. So we don't publish a fair bit of the indigenous data, so we haven't done much on the care work. So that is the one thing we wanted to do in the next round of funding. So there's a fair bit of a challenge. I think the people are talking about these peers. There's a challenge in accessing the intra-peer community as well, because our community is so widespread. It's very difficult. Somebody from the Flux community don't understand the ecology community data. Somebody from the ecology don't understand the Flux data set. And then the program they use also different. Predominantly ecology community are the R programmers, whereas the remote sensing or the Python, they don't understand R at all. So that is a bit of a major problem. So for example, if there is a variable somebody has written like a AH, it's absolute humidity, you would know, but nobody don't have a clue. So that is the main reason we use the vocabulary to describe all these things, so that they click on the URI, they know what it is the definition, what is the source of that definition as well. So I think one of the other challenges for the talking to the other domains as well. I think we work very big on data standards. We don't publish anything apart from it doesn't have a data standard. If there is no data standard, we build a data standard. For example, there is no global data standard to manage the site survey data. We built a data standard to manage a site survey data. So for example, the same data standard is used by the department, BDR project to manage their site survey data set. So again, so for example, a lot of our raster data set is in the cloud optimized GeoTIFF, and then the point cloud is a COPC standards as well, because this area, it keeps evolving. Our infrastructure also keep evolving as well. So however, if we move to that, some of the, for example, the models may be using, for example, the NetCDF file. We manage those files in a NetCDF as well, so that they are not cut off, kind of a thing. So yesterday, somebody, I think the climate one's talking about the NetCDF format of the AGCD. So the AGCD format, NetCDF is normally uses a CF convention. If it's required, we publish in a multiple standards as well, so that it's meet the community. So one of the main challenge in this community is to make sure that the data meet the fit for purpose. So we're very keen to engage with the community to make sure that we provide that. So a lot of our data is the observation data. That's a primary data set. So you can derive a fair bit of the products out of that. So for example, from our surveillance data set, it's just a point intercept data set. We derive a ground cover data set from that one. And then you can derive a species composition data, for example. So based on the community needs, we derive that, and then so that the community can straight away use that. So for example, if you look at the most of the ecology science, they use the ANU CLIM or BioCLIM because they need the temperature or the weather-related information. So as part of our pipeline, we pull the data from the ANU CLIM and then provide the weather of that when that visit happens, so that they don't have to run that simulation when they go and do the thing as well. So these are some of the add-on information we provide. So some of the things, is the challenging is to make sure that it's real-time processing of the data. This is, which is very critical, especially during the bushfire. I think yesterday somebody was talking where, the remote sensing don't know because there's a full of smoke, which they rely on the calibration validation of the ground truth sensors. If we don't have that data, if we provide that data after 6 months, it's become almost like a useless information. So that is where we are very keen to work on in the current round of funding. So make sure that especially the critical infrastructure, we process that data almost at the near real time and then make that available. I would stop there. Thank you.
going to have to look at the slide up there because it's very small here. Hello everyone, my name is Mark Rabine. I'm representing IMOS. My role at IMOS is Director of the Australian Ocean Data Network, AODN for short. The AODN provides the data infrastructure for IMOS, where we're a component of IMOS. IMOS collects and manages a large national program of data collection. It includes very diverse types of data sets like ocean radar, satellite remote sensing, various moorings arrays, ships of opportunity, and even animal tracking, amongst other things. IMOS subcontracts its data collections out to 66 different IMOS facilities and sub-facilities. And those facilities are responsible for collecting the data, and they use quite detailed operational procedures, standard operating procedures to collect that data. These procedures document the methods that they use and include the data quality control procedures that they apply to that data. They're contracted to collect data and pass that data on to IMOS and the AODN for storage and dissemination. They do this by delivering the data in standard format, and the format that we use is NetCDF. It's a multi-dimensional, self-describing type format. It includes some data and some metadata within the data files. The metadata themselves within the NetCDF conform to an international convention, the CF convention. And it's those data files that are uploaded into our cloud repository, and that all those various data files form like a data lake for us, and it's the foundation for the AODN and its systems for disseminating the data. All our data are open access from IMOS. It's all made available under Creative Commons Attribution License. And these data are made available to the AODN portal. It's a publicly accessible portal. The data sets themselves are registered into the portal using ISO 19115 metadata standard. It's a popular standard amongst many in Australia and internationally. We also manage and maintain a range of vocabularies for units of measure, parameters or variable names, instrumentation types, and also some organisation details. The portal itself provides search and discovery services and some spatial visualization, as well as a data query subset and download function. These functions are supported by some geospatial services. One service is the Web Map service. It's providing the spatial visualization component, while the Web Feature service provides the data query and download services. Those services are all GIS compatible. We also offer a Threads and OpenDAP service, which is native to NetCDF. It's very popular in the oceanographic community. So these services also allow other organisations to participate in the portal. They can publish their data via the portal. So these organisations, if they want to publish a data set, they'll need to provide a Web Map service and a Web Feature service, and then also the metadata record to describe it. These data sets still reside with the host organisation, so they're hosting their own data and they're managing and maintaining their own services. So the data ownership and data sovereignty are sort of intact. but it still provides a way to deliver that data through the portal infrastructure. So with the IMOS and the 16 AODM partners who are contributing data in that way, they sort of act as the data producers and the data sources within our data network. And it's the portal that provides the sort of the brokering ability to broker users to data providers, and in that way they access the provider's services for visualization and data query and download. So the data users for us are industry, the government, the research sector, and also general public. And while the portal is really there to support some human interaction and discoverability of that data, the underpinning services are there to enable machine-to-machine integration. So over the last year or two, we've undergone some reviews, and this has identified some gaps and opportunities in how we might increase uptake of our data and enable further integration, both within the sphere and even within our own data collections, as well as across spheres. And the main ones were making data easier to find, so improving how you search and discover data, making data easier to use. So this is about making sort of ready-to-use data, so data that's already been combined, and then data that is also easier to integrate with modern API services and other integration methods. Various committees also identified different data sets that we require to answer new science questions. And so that included pressures and impacts, and then also biological and ecosystem data, and also the ability to deal with data that's collected by our Indigenous partners, which is a sort of an emerging area. Because we deal with, or potentially deal with sensitive data, there's an emerging need to incorporate a service for an identity provider to allow us to authenticate, authorize access to sensitive data sets. So the diagram on the top left is the shared analytical framework, and it shows environmental information supply chains. This was a framework published earlier this year by the ARDC, WABC and WAMSI, and I thought I'd include that to show both how data is collected and how it gets to being used through these collection, curate, integrate and analyse layers, but also then show where IMOS and the AODN fit into that supply chain. Supply chain is sort of indicates that there's more than one actor in the process, so the bits where we don't fill the need means that someone else is filling that need. And so it's a good indicator of how people need to work together to be able to get data from collection to use. And for us at this conference, it highlights the integrate and analyse layers. Thank you.
Great. Hello, everyone. I'm Kelsey Drukin, and from Access NRI, I'm one of the associate directors. for release management. So today, quickly, I'm going to just run through a few of the common data themes for us, similar to others. But first off, we are a new NCRIS facility, so for anyone who does not know us, I wanted to introduce who we are. So we launched last year, and we are a software infrastructure, so we do not have any physical infrastructure, such as instruments or big computers, so we focus on software that also produces large amounts of data, so that's where we get into the data space. And for us, a key goal is building and enabling the climate science research community and predictive capacity for the climate systems. For us, the key compute and data infrastructure that we use is NCI. So actually, Ben will follow up and probably tie together quite a bit of what's key to us, similar to Rebecca before me. So our compute and data storage really for almost all of our community resides there, and it's critical for us. We have a wide range of data sets, so some of the discussion that came from talks yesterday, you heard of different flavors of models and data that pertains to input for assimilation. And for us, model output is a big component, and that's at the petabyte scale. And again, NCI is critical for us because not only do we need compute to run climate models that our community uses, we need compute to analyze most of the data output because it is at such a great large scale. In terms of standards and best practices, I'd say that our community has a range. So we have federated collections of data that that feed into IPCC reports. So the Earth System Grid Federation and CMIP models would be a good example of that, where there's high levels of curation and data standards applied, lots of good practices. But then we have a range of data down to model outputs that are generated near real time with our researchers that need to be able to analyze, they might want to share, and so there's a range of best practices and a place that, for infrastructure, is a space that we can help and support there. So ESGF and CMIP is one of the probably key international linkages for us, and that's really through NCI and Ben's team with work on that front. Let's see, a few points that I wanted to make, again, based off yesterday's discussion and maybe for discussion following here. In terms of emerging needs or missing pieces and challenges ahead for us, access to petabyte scale storage for climate simulation outputs is critical. And how do we help enable that for our researchers? And again, for everything from storage that's needed in the moment with people doing their research to storage that supports the reuse and sharing of more curated outputs. And since we're here talking about integration, I thought that was another point to make for our community. So again, we're tied to large compute, both to look at the data, to store the data, and how do we enable integration across the spheres for the integrated Earth, and how do we do that for people that might not be working on HPC systems or familiar with the skills and training that's needed. So I think that that's an area and a gap for many of our communities. And I think that's the key points that I wanted to make.
Thank you, Kelsey. Good morning. I'm Hamish Hollower. I'm the Director of the Planet Research Data Commons at the ARDC, or Australian Research Data Commons. The ARDC's purpose is to provide Australian researchers with a competitive international advantage through data, and our mission is to accelerate research innovation by driving excellence in the creation, analysis and retention of high-quality data assets, which has been a really key theme, I think, of today and of yesterday's workshop, particularly as data came up time and time again as a key challenge area, as well as a key need to integrate across multiple spheres and domains. The ARDC has been providing foundational technical and social infrastructure to address those challenge areas and those missions over its lifetime. And we've been doing this in collaboration with the Academy of Sciences, universities, our NCREST colleagues here, our universities, and our international collaborative partners such as CoData and Research Data Alliance as well internationally. I think also, as Tim said in his opening remarks today, actually, we need a common language and alignment between our descriptors within and across our domains, and a consistent vocabulary and taxonomy to actually be able to integrate between our domains and our sectors. And the AADC has been providing some of that infrastructure to enable those outcomes. In particular, we provide fair data management, policy and integration activities. So work on policy frameworks, capabilities and systems required to make fair data available and accessible. This includes working with the domains, but also across the 42 universities that have institutional repositories that store and manage that data as well. We work on the standards and frameworks to enable discoverability, such as the schema.org, and also some of the work that Guru was talking about in terms of defining those standards and making them more available and being able to describe them and publish them. So Research Vocabularies Australia is a service that AADC operates, which has about 430 vocabularies in it, enabling research communities to accurately refine, discover and align to those vocabularies to enable discoverability and integration. We also work with the policy and government departments in open access and data across Commonwealth and state jurisdictions, and have some other infrastructure required to support fair data, including Research Data Australia, which catalogues about 200,000 data sets across those spaces in the country. As part of that activity, we also run a National Persistent Identifier strategy, which is the implementation and some of the work around digital object identifiers, linking that in with the ORCID work, which the Australian Access Federation leads, research activity identifiers, so what's the research activity in those projects, and that allows us to really link those impacts, so between research funded, research done, data that's been developed, the project and the outcomes. As part of our program as well, we provide digital skills training and outreach, so uplifting Australia's data management and data science capability, and that's both for researchers but for the people that support researchers as well, so data management specialists, librarians in our network. We also provide research tools, platform, compute and storage. The Nectar Research Cloud serves over about 8,000 researchers per annum, and it provides a place for researchers to collaborate and innovate using cloud-based technologies, and also to host infrastructure for their outcomes and outputs as well. We also provide access to multiple domain platforms, and even here in the audience, we've got EcoCommons, we've got the Austraits, and we've got the Australian Scalable Drone Cloud initiatives that are providing those services to those communities. And that's across 21 platforms and projects. And we also provide targeted work into data challenge areas. So previously we've been working within the bushfires area, and we've been doing food security challenges. So focusing that effort on particular societal challenges that Australia is needing to address. In my role, but ARDC is refining that strategy to focus that effort actually on 3 domain areas and 3 thematic areas. That is the Planet Research Data Commons, the People Research Data Commons, and Humanities and Social Sciences and Indigenous Research Data Commons. The diagram to the right here describes some of the aspects that we have and our focus areas that we will focus on as part of the Planet Research Data Commons, and this is informed by consultations with over 200 stakeholders across government, research and industry. Trusted data and information supply chains to address some of the societal challenges that we've all heard about over the last couple of days. We do need to integrate between these domains, and the space is becoming much more complex and much more harder to navigate. Trusted data and information supply chains has came up as a consistent area where there is issues at a regional level that require data across domains to come together. In particular, some work that we have done actually where we all are at in Perth, looking at the Pilbara region, where there's $100 billion worth of effort, sensitive biodiversity and environmental values, and also socially contentious as well. So there's some really strong use cases that we actually kind of need to come together across our domains to actually address those areas. And that, as Mark actually said, and I'm going to just borrow your slide there, Mark, actually, because that was nice. Beck gave us the one slide only for our infrastructures, and like, so you know, we all collaborate. Yeah, we're all friends. Yeah, but to reach our use cases, say cumulative impact trend, biodiversity trend, and those reporting elements, we need all to come together, and we need that to work across all our respective domains and our respective capabilities. In a survey that we did actually for this culture, collect, curate, integrate and analyse, when we looked at the capability maturity across our sector at those areas, we had high scores within collect and curate, which is really a testament to the fantastic observation facilities that we have developed within Australia. But integrate and analyse were low scores and areas that we need to actually kind of work with, which is consistent, I think, with the message of today and yesterday. Likewise, also, industry and government need to be involved in this picture. Decision support, the work that we do is leading to impact, and we want to lead to those changes on the ground, which is a really important mechanism. Another focus area that we will be looking at is integrated data set and services, so lifting that FAIR element across the line, across all the domains, working with those programs such as World Fair about implementation. A lot of our use cases that we've come up with is people want a secure and safe space to bring data together in a lens capability. So I want to look at phylogenetics, I want to look at a coastal, I want to look at biosecurity. And there's certain areas of security and access that need to be sorted out for those lenses to actually kind of work. And this is actually an important point that Kelsey and Mark actually kind of made as well. We'll be looking at the establishment of data spaces, allowing that to actually happen between government and industry. We also see integration across common pipelines, so video, audio, and imagery. This is run by multiple kind of groups. How do we combine that effort and combine those methods to actually make a national capability to enable that access to work much more effectively? Modelling, analytics, and decision support infrastructure, which is around the top there. It's about networked modelling and support. What are the methods that we use to describe those models? How do we link that between our Jupyter notebooks, our Python code? Kelsey and Beck, you talked about having a modelling commons approach to this. This is also a strong element that came out within our consultations as well. How do I find the models that are actually useful for my use case? If I'm a researcher, how do I find that work and how are they actually tied together so I actually can repeat them much more easier and much more available as well? Thank you, Tim. Yep. And likewise also, when we have those models available, how do they go into those new advances of digital twinning, and also how do we do AI over federated data collections? Last but definitely not least also is a care and skills program about lifting up our ability to implement the care principles across our infrastructures and as an embedded principle about the way that we do business, and also bringing people together to focus on the digital skills needed to do integration across the domains. So thank you, Tim, and over to Ben. Thank you.
Very good. Okay, I've got 2 slides. I was given special permission because I was the last speaker. The first slide is what I call the rocket ship slide. And the second one is about challenges which sort of affect us all and fitting into this NDRI process going forward, and some reflections of me and what those challenges are, and perhaps some remedies. So it's either my broken record slide or breaking record slide. So that's the second one. So on the first one, supercomputers are incredibly powerful platforms in terms of doing many types of science, but they're not just buying a supercomputer and plugging it in the wall and expecting it's going to do all of this stuff. It's many components other than that, and that in itself has been its own challenge in our funding sphere or funding world. So in the centre there, having compute with capability, the power and capacity is all fundamental requirements. You can't have just a fast computer and a small one. You've got to have it, this full capability system, and that's a technological challenge of feeding these things together, keeping it up to date, integrating and keeping it stable and robust and secure so that you can come back day after day and it's still churning away and doing that stuff. Down on the bottom left, some years ago, we created basically this integrated Earth data sets on NCI, making them computationally ready, HPC and HPD. Well, that says HPC and HPC, but HPC and high performance data, a term that I crafted up actually at some point and put in a paper. But our idea was we had a number of organisations and we were going to focus on the Earth and really sort of create that capability inside the research infrastructure to do that. And that's been tough work to pull that together and liberate lots of data sets and bring them together and actually fashion them in the right way. On the bottom right, curated, integrated cutting-edge software code and release systems and techniques, and pulling that together for the best purpose that we can get to it. So that's both software and its people skills to make that work. Top left, and sort of the numerator part of the equation here is models and data to information is what really these things are about. The way to get there is by problem solving. And what does that mean? It means you need expertise across the board and many multi-way collaborations between different types of scientists, different types of technical people, hybrid skills to get to that end point. And why are we doing it? Well, it's a scientific discovery platform. It is about simulation analysis and predictive capability and producing knowledge from that. And there's many flavours of that. It's not one research project, it's many, but it is a fashion, of how to put a supercomputer together with all of the fundamental components. So that's my capability slide in a nutshell. Various flavours of that have come through the Access NRI and Boscope and IMOS and TERN and all sorts of things, are on this system. Bureau of Meteorology does their research work, CSIRO, all collaborating, around this system. So my next slide on the challenges for national digital research infrastructure. And these are my reflections of the major challenges. They're not the technical challenges underneath. They're about what is this all about? What are we trying to do? And where are the challenges to that infrastructure? So one is this is scientific infrastructure targeted for our scientific purpose. And we need to work out what it is, who we're collaborating with, harnessing the skills, the rare skills, around these systems. So it's scientifically driven HPC and HPD in our space. Particularly, I've been working on integrated Earth. There's another one around health and medical science. There's another one around astronomy and astrophysics, general relativity world of gravitational astronomy. There are other ones as well, humanities areas or whatever. They all sort of come together at some point, but actually the collaborations happen around these core capabilities as the main element that drives the science forward as a national capability. So we need to understand our national and regional challenges to do that, and we need to enable a lot of things at the same time. It is not just education and academic research, it is federal governments, state governments, research and international. It allows both what I'd call a collaboration, real collaboration, and also people to do things what I'd almost call anti-collaboration, because they don't really need to talk to each other to make use of the infrastructure and make use of the expertise, because once you bake it into software and infrastructure, other people can pick it up. That's its value, that's the acceleration through these things. Second one, and we're suffering a bit from this at the moment, is a lack of confidence, decreased ambition, ineffective rat running. That is happening right now because the cliff is coming up, and while there is an NDRI roadmap around this that actually hasn't sort of grasped the nettle, it's late, it's now short term to do various things. Similar things are happening elsewhere. It's not just the NDRI. We talked about access model and CMIP modelling with a timeline looming, and now it is, what can be done in that short period of time that's left to us? It's really short-term science, it's not big vision stuff. And this is not the way science is done in Europe when they get coordinated, or the US or other places. They have a long-term strategy and then they fashion inside of that. We are at the point of just going, we don't even know if that's going to be funded. We're literally like increase in the past, it got to the cliff edge and then it got rescued, in an afternoon. Next one, redshifted and dark data. So I just created this term redshift overnight. But redshifting, in my view, is because the computers are accelerating away, they're getting much more powerful, how do you access the data, right? If the data's not co-located with our HPC and fashioned for it, it's getting slower. If you really think that you can take data and you can put it elsewhere and somehow you can suck it in, computational people are worried about how to get efficient cycles. How can I push that thing through as fast as you can? I/O systems are really slow when you think of the computational cycles. The wasted power of a supercomputer is really critical. We used to talk about what would data be on the outside? That's pretty crap, out to tape technology and whatever, as fast as tape speeds are. You cannot feed those things, into the system fast enough. And then we say, well, we'll just distribute the data all over the place and we'll stick it behind a web server. That's just crazy stuff to try and innovate and do the fastest thing that you can on computational science. You need that data there. It's multi-factored data use, so it needs to be available online, everywhere, in the best sort of standards that you possibly can, not send it off to PhD students and then say, go and fetch data, go and talk to my mate, they'll give you a brown paper envelope, send it back. All of that sort of stuff is just madness as a national strategy. Dark data is this sort of data rescue things, or things that are being pocketed off through funding spheres, as they were. I've got some funding, I'm going to put it over there, I'm going to do the best thing I can with that data. It doesn't get really liberated, for everyone else, and it gets, over time, the purpose for that data disappears. So it needs really a good national effort and skills across the board to make that data much more visible. Fourth thing, data doesn't integrate itself. You might ask, why do you integrate data? And it's a good question, but what is data integration? Yeah, it's got standards and whatever, but it's going to take software to integrate that data. It's going to take all of those fundamental components and have to work together to make that happen. Number 5, costs are significant and we're generally still very much the leaners. I made the comment and have various times, we don't put satellites into space to observe, physical phenomena. We don't do the R&D around it. We don't largely we don't curate that data, and we're so cheap we won't even store the data for the local, for the local groups to actually use. And if you compare that to the capabilities of the individuals, the role of infrastructure should be to make people as capable as they possibly can be, increasing the ambition of what could be done. That is the attractor. That's what drives us into this area. It's not doing administration, it's not doing standards and whatever. They're just artifacts to make it happen, which goes to my first point. What is this about? What are we going for? You need to energise the system, around this. Costs are significant. There's cross-jurisdictional issues. There is a certain race to the bottom that feels very attractive. It's the way I would equate, I want to buy or build a house, so I'm going to give everyone a Bunnings card. And you can go to any Bunnings you like and you can go build your own house. It's not the way you build infrastructure, and it's not the way we build national rocket ships. I think that we can do a fair bit better than that. Anyway, like I said, I'm a broken record, or we're going to break some records, you know, going forward. There are things to think about of what is this infrastructure about. There's an opportunity to grasp the nettle, and there's plenty of challenges on the government side, and they do need to understand what the vision is, just not what the tasks are. Anyway, thank you.
Thank you, Ben, and thank you, everyone. Well, Ben's kind of just solved it there, so we can take an early lunch or we can have a conversation about it. I think we probably should put it to the floor. I did want to acknowledge also, so the group that we have on stage are all representing various NCRIS organisations. There are other NCRIS organisations that operate in this space as well. The only reason they're not on stage is because they didn't organise the conference with us, but they're just as much a part of the family. So we've got Pawsey, there are members from Pawsey here in the audience. We've got Atlas of Living Australia, we've got Oren, and you know, a bunch of others. I apologise if I've forgotten anyone. So there is a big cohort of NCRIS capabilities that operate in this space. And I think it was really interesting to hear, you know, from all of the groups that are on stage about the different capabilities that we represent as an organisation. But even just the way we stand up and talk, we're already a bit siloed, right? And Ben pointed to that, you know, and that's a function of the way we've been funded over many years. And there's great opportunity that's come from that, so it's not all a bad thing, but it is part of the structural issue that we face. And we try to get around that with groups like NESIF, which is the National Earth and Environmental Science Facilities Forum, soon to be renamed. But you know, there are groups that do collaborate really, really well. But you know, we're open to suggestions about how things could be restructured, how things could be changed. And the intention of this period of time we have now, where we want the audience to engage with the panelists and with everybody else, is to start to think about what we're missing in this research infrastructure that we have available to us to allow us to do the integrative science that we talked about yesterday and that we've talked about over the last couple of days. So what are the gaps? What are the things that are missing from an infrastructure point of view or from a data point of view, you know, as infrastructure? So what are the things that have come to you over the last couple of days or have been nagging at you for weeks or months or years that we're just not addressing within this ecosystem? And I'll open that up to the floor for questions, and I'm going to have to ask someone to help out with that. Actually, I'm going to just do it. I'm going to take it straight up to Simon. Thanks, Joe.
Shall I fire off? Thanks, that was really interesting. I think it's really important to get, so I applaud the approach here. I think it's really important to get research infrastructures talking in this way. I don't know whether Ben hijacked the extra slide or whether he was asked to, but I thought that was really great. And that's really helpful to frame a discussion. And I'd have liked to have a little bit more of that challenges in the other presentations. Sometimes you alluded to them, but you know, to have that space to, because I think this is really, really helpful as a guide of what we need to address. There are perhaps some things missing. A lot of it hangs off number one, and making that case, that value proposition to government. You need scientific allies to say, look, we need this infrastructure to do our science. You know, otherwise we can't answer the questions that you're asking us to answer. As part of the national strategy, as part of global requirements. So a lot of it, you know, I think hangs off this making the case underneath one. And I really we hear a lot, number 3, not keeping up with computation because we're not curating the data enough. FAIR is supposed to be about, and this is often neglected, FAIR is supposed to be about machine actionability. It's not just about curating the data and sticking a DOI on it. It's really about making the data actionable for those scientific purposes and so that we can answer those scientific questions using that HPC for, capability, of course, but we can't do that unless we address number 4 here. And software obviously is important, but I would say that without the metadata, without the investment in that detailed curation that I talked about, we can't achieve those things. But we've got to show that that investment, and I think in the response to Donald's question, we've got to show that that investment in curation is worthwhile. We can't just leave it to AI either, because it'll be rubbish in, rubbish out.
Does anybody want to respond to that?
Sure. Thank you.
It does take a couple seconds.
It does take a couple seconds. It's good to go on. There we go. Thank you, Simon. I actually agree with you. Actually, us coming together and targeting some specific use cases which are addressing societal issues and challenges is a really effective way of actually looking at these kind of challenges. Whilst there is the investment that we need across broad scale integration, metadata software, metadata descriptions, I think having those cases and meeting those kind of science priorities actually really kind of focuses our attention, because, you know, frankly, integration for integration's sake is really, really difficult and really, really hard. And I think we've seen this actually in some other initiatives that we've had in the past, where focusing on those efforts and focusing on those areas really kind of galvanises our infrastructures to work together and to see where those challenges are and what those gaps are and that need to actually be existing. I think it also enables us to actually collectively look across those new technology suites that we're not actually maybe looking at wholeheartedly at the moment, about what we can kind of do and how we do that collectively. So as you kind of mentioned AI as a tool there, obviously that's hot on everyone's kind of topics there, but how do we do that kind of collectively so we're all enabling that function, and we also are in the same position to actually utilise that new technologies and those kind of functionalities as well. So I agree, and you know, with some of those kind of cases come out in our national science priorities, and as Ben actually articulates here, you know, regional challenges where we've got new energy requirements, you know, increasing population, shifting climates, provide those use cases in spades, actually. So, yeah.
Thanks, Simon, as well for your comments, which I absolutely agree with, because you pointed to my slide, so that was good. One of the things that is really critical, you know, in all of this, and we were having the problem yesterday, or having a bit of a joke about the language, right, and understanding what each other meant by various things. And we did have a joke off the side. We don't know what a model is, but we sure know a supermodel if we saw one, right? But the people who are technical have not necessarily come from a pure technical background, or maybe some of them have or whatever, but that understanding of what is the problem that you're trying to solve is absolutely critical. You know, just applying standards for standards' sake will only get you so far. You need leadership, intellectual leadership. What problem are you trying to solve? You know, what are they trying to solve? Making a reach across. You can't get all of the way there, you know, by yourself, but you can do certain things, and that will accelerate, you know, the research that's going on. The other thing that's really important about these infrastructure layers is the translational capability. And I don't just mean to industry, although that is one aspect as well, and it's hard to talk the industry language in the ecosystem or whatever. How do you build up those collaborations? But when you're solving things well on this technical level and standards and whatever, you can start to apply it to similar areas very quickly, and you can take other people who have been sort of in the dark and not helped and lift them up. But you can't just go, oh, I've got the solution for you, and you just whack it in there. You know, that's not going to work particularly well. Or they can solve it themselves, just get a smart student or something or other, and they'll just take it on. But if you're really going to uplift, a lot of that's going to come through people who are in this sort of hybrid infrastructure-y, sciencey sort of space, working on things because they're problem solved in another space, and they will have a little bit of the time to try and do that translation. Not like a PhD student who's got to get their stuff done and out the door, or a research activity which is trying to do the other part of the frontier, sort of a sharp frontier, as it were. So it's a really interesting ecosystem in that space.
Thanks, Ben.
Hi there.
I've got one here first.
Elisabeth Akhtarov. I manage the EcoCommons platform, which is an ARDC-supported platform for environmental modeling capabilities. And I really like Ben's, metaphor about let's build our rocket ship. My question is, how do we build this rocket ship without, without losing talent, but also projects that are kind of linking the different NRIs together to short-term contracts? That's my question. And also, what role do the NRIs play in champion for those projects that are driving innovation?
Great question. Who wants to take that?
I can go.
Go, Hamish.
All right. Thank you, Alyssa. Very targeted and very pertinent question as well. And I think what you're... in those programs which are innovation-focused, innovative-focused, about bringing together those data, bringing together the models to specifically address a use case. We've seen sustainability across our systems as a difficult aspect for those kind of projects to actually work with, and also to uphold and keep and retain skills and talent, as you kind of put it. And I think as we've become more mature in this space, it's actually about recognising some of those architectures and those skills that can actually endure going forth. So using those programs and recognising them as innovation, and how do they, and what's their translation pathway into enduring sustainability and enduring architecture, so they're able to be managed and maintained. So I do recognise that there is a slight gap there at the moment, but it is about maintaining that network across our infrastructures and also recognising the importance that those platforms and those projects play in this whole ecosystem.
I was just going to add, maybe addressing the later part of your question with the question of what can NRIs do for the broader community. Something really important for us at Access NRI is the community dimension, so community building and also understanding how we can support and find that hybrid space that Ben referred to there, with all these different skills that don't just come from technical backgrounds and infrastructure space, the science space. We're really looking at how to complement and uplift across all. So it's been really important for us to build and nurture different aspects of our community. And I think what's been really exciting for me is that as we've been going through that process in our startup, we also have these overlaps that naturally fit with many of the facilities up here. So we're seeing research engineers or scientists that are crossing not just one infrastructure space, but translating through. And I think that is something that is really important and also something that we should work to have more of.
I think I'd just add as well, I think it's worth remembering that whilst Ben's absolutely right, we need to have long-term vision, long-term investment to achieve the goals that we need to achieve. The NCRIS program is unique and it is fantastic. You know, it is a fantastic program. And whilst the road gets rocky from time to time, the road's kept going since 2006 and it's going into the future with investment from different governments, you know, bipartisan support. So we do operate in a pretty privileged environment when you look around the world. I think it's worth recognising that. We have a question down the front here as well.
Yeah, hi. Paul Leopardi here. One of the things I always have been doing quite recently is just understanding what is happening with provenance of various sorts of data. And then I found that really what you needed to do to understand the provenance was actually more like an onboarding process, being inside a project in order to understand what happened in the project in order to actually use the data, because then you have a much richer idea of what things mean and why they're there. So how do you build institutional knowledge and onboarding into something like a machine-readable provenance?
Great question. Guru or Mark, want to make that one?
Yeah, thank you for the questions. So there is an ontology called Provo. So you can build a machine-readable propagation, the provenance information. It is not a trivial activity per se, but with all these things, we need to have a tool to make that easily, to build it, and then the visualizable as well. I think Mark alluded to everybody's about the metadata standard, so that is where the fair bit of this information can go through as well. So how the data is, for example, in our case, in the ISO standard Mark mentioned, so there is a specific aspect where you can talk about the data quality, and then individual aspect of the processing quality, and then if there is any error propagation quality and everything. At the OGC standard level, there is a error propagation, uncert ML is there, and then NetCDF is a classic example where, all the approximation, everything is propagated as part of the, the format. With the file format, we can do it, sometimes, it doesn't come out per se. And one of the major challenge with all this is that, you have a data and then the metadata, it's all explained in the metadata. Once somebody downloads the data, all this is lost, kind of a thing. That is the biggest challenge, so that's why, we are working towards more on the research object capability, where all the contextual information propagate with the data so that it will never, lose the data set. That is one of the biggest challenge, we face, especially in the ecology community. So that is where, we, as a project, is moving towards.
Yeah, the capture of provenance information has been a real difficult job historically, and I think it's still a difficult thing to do now. So yeah, capturing the information as you go through the processing steps, or even capturing what's detailed in the standard operating procedures is still an area of work to get through, I believe.
Thanks. I think David's got a question.
Me?
Yep, sorry.
Sorry to steer it back to the funding issue again, but since Ben brought it up, and then Eliza, I think we're all here because we want to move this forward faster. And when I reflect on what is limiting that, it's not lack of ideas or not knowing how the solution, it's this perpetually shaky ground we're on. Like, how many people here were majorly impacted in their projects because of the NCRIS delays in the road mapping? And maybe lost essential staff? Raise your hands. Who was impacted by the delays in road mapping and lost essential staff who are hard to find because developers are hard to find? We talk about how do we recruit more developers, but we can't retain developers because, we all know this, right? But the problem is if we're trying to solve this, we're trying to create an emergent property in this complex system of how we solve this, and if we ignore this fundamental thing, like we're all pushing in one direction, but our ability to push is drastically reduced by what feel like systemic problems. And so I feel like I'm always unpopular when I bring this up, but we can all be 100% effective in doing good science, but if that's reduced to 20% by these roadblocks, we need to acknowledge that as part of this discussion around how we can do it effectively.
It's a good point. Does anybody want to comment on that? Anyone in the audience or on the stage? Rosie? Can we bring a mic down to Rosie? Oh, you can come up. Yeah, why don't you? Oh. Sorry, Rosie.
I am absolutely acknowledging the challenges. In this particular instance, ARDC hasn't suffered in the same way as some of the other organisations, and I do want to say that as well. I do want us to remember, those of us that have been in the space for a while, and there's a few of us, what enormous strides we've made from NCRISIS in 2015. I was in a different facility, but we got to within 3 months of losing all 138 staff. So we've moved to a position where we do have roadmaps. For the first time, we're about to have an NDRI strategy. So yes, it's tough, but I think we have made progress, and I think the types of conversations we're having at the Integrated Earth Conference, and indeed the way the different NCRIS facilities are working together, is so far forward from where we were a few years back. And all I'm trying to do is to keep our heads up. We are making progress. It is hard work, but I think we have to look at the gains we've achieved so far and keep putting that message through to the federal and state efforts that support us. So I'm just putting yeah, it's tough, but it's getting better.
Thanks, Rosie.
If I can add, I suppose one of the things that I always talk about is community, and I think that's one of the reasons why, like, one of the ways we can be resilient to those types of, disruptions that we continually have as well. And that's something that, like, over the last, similar timescale that I've been working in this space, that the community around the Earth and Environment NRIs is a lot stronger than it was, 5-6 years ago. I know that as the data leads, we spend a lot more time together. I know lots of the other organisations spend a lot more time together. So that also provides us, the people factor provides us with a lot more resilience than just, the tech solution.
Very much agree. I've got a question.
Yeah, I just want to hear your thoughts on the intra-sphere data integration. Shouldn't we think about the within the sphere to integrate data, because and then see how those social and technical solutions that use and adapt that to do the inter-sphere, because within the sphere is also we have it's difficult to integrate. So for example, geoscience, you have a mineral, geochem, geophysics, all this data have to be integrated for mineral explorations. So those things that we learn, or techniques, or social community, or can those be used to translate to do the data integration between spheres? So I just want to know your thought on this.
Yeah, I think I'll raise what Simon was talking about earlier and what our experience has been through One Geochemistry as well. So, geochemistry is a really heterogeneous community in itself, and that is only a subset of geosciences. But looking at things like different scales of community and different scales of standards in FIPS and FIRS, so the FAIR implementation profiles and the FAIR enabling resources, has been really interesting to us. So we can kind of go in both directions. So trying to integrate within a small group that has kind of infinitely diverse data models can also work the same way. So, yeah. The details are in Simon's slides.
I think major thing is the education and training is a major thing. I think ours is a classic example where the intra-sphere integration is a major challenge, because each of the community is so wide in our sphere, so it's very hard for somebody to understand the other data set. They don't have a knowledge, so it's purely the upskilling. The education and training is the major aspect. And the fundamental to all this is to basically use a data standard. I don't know whether Ben was bagging on the data standard or he was critical on the data standard, but that is the starting point. It doesn't solve the problem. That is the starting point to solve any of the problems. So that's why we are big on the data standard. We don't publish anything. For example, we don't even publish the Excel. If somebody provides an Excel, we tell them, convert into CSV, provide a data dictionary, otherwise we won't even publish your data, because after 2 years, the Excel version changes and people can't even open that Excel file. That is the classic example. I think sticking to the data standard and then the education of training for the inter-sphere is the first step towards the making the data integration possible. And then we are big on probably it's good to have like a use case driven kind of a thing. So I have some use cases where people want to access a certain data set, and then we can build, for example, Jupyter notebooks and everything, and make that available, and then that will expedite the fair bit of this process.
My point's very quick. I just wanted to add to that something that I think often can get lost in the detail is that people are just as important. Like, we need the training and upskilling, but also just like you would need specialized skills for maintaining expensive investment in equipment, you need people that also have the skills to offer that support across all of our facilities and space, and in addition to training. But I just think that's a really important thing for our future and getting, number one there tackled.
Yeah, it's good. So first of all, just go to Guru's thing. Data standards are necessary, but they're not sufficient. That's my mathematician's answer, to that thing. Like a lot of these things, they're really critical, but we've got to harness them for something. Otherwise, we need to integrate data. Why? What's our mission? What's driving us there? And we need some drivers, to push that envelope. In all of this activity, and the challenges are big. I wanted to pick up on Kelsey's comment and the one for the back. Sorry, I don't know your name, but it was about these funding cliff, issues, and that is this infrastructure stuff is investment in people. The infrastructure doesn't solve anything on its own. It's people who are driving it on. It's people. It's collaborations. It's understanding and seeing the future and whatever, and giving opportunities for others, then who are the beneficiaries, is really what's happening off this infrastructure. Done right, this stuff just works. I was talking to someone the other day about the old Landsat data. Do they know what Landsat was like? About 15 years ago, if you want to work on a Landsat, satellite image, you would have to ring up someone and you'd have to say, I want this little bit of square on the a particular timestamp, a little particular segment, and they would, through a vacuum tube, send it down to someone in the basement who would go and fetch that thing, and then they would post it back and you would get your slide, right? I mean, it's just diabolically, bad, like that is not the way you'd want to do things. And that's what infrastructure does. It starts to enable, and accelerate, that ambition and get the most out of people, all of those legacy problems. So standards are important. Which ones do we want to choose? How do you refine? How do you push that boundary point? Is what is driving us. But it's the people, at the end of the day. How do you tackle those challenges? We're not just polishing the knobs, it is actually driving things forward.
Excellent. Oh, we've got 2, 3. Oh, we've got lots of questions and we've got like 1 minute left. Okay, we're going to go to Andy first.
Yeah, okay. Lots of questions, but I've got the microphone. Andy Hogg from Access NRI. I wanted to say I agree with Rosie's optimistic worldview, and I think we do have a lot of opportunities here and we should be looking for those opportunities. And on that note, I've been sitting here for 20 minutes looking at Ben's extra slide here, wondering really what does he mean by, well, I guess at risk of giving him even more oxygen, can you detail exactly what you mean by the leadership role we could take under Section 5 there?
Okay, I'm going to give him the chance to answer that quickly, and then I'm going to take the other 3 hands that were up as comments before we go to lunch so that everybody gets to say. So you can take them to deep now.
Yeah, my comment around this one is we've done pretty well of harnessing what we can in the Australian area, but Australia has a regional role as well. And if you compare the GDP of Australia and the impact zone, it is much broader than Australia. And by looking a little bit further on, we might actually see the problem a little bit differently and sharpen our focus of what we can do and what the opportunities are for other collaborators. If you do go into the Australian setting alone, what you see is federal, state, research, whatever, barrier points and whatever, but like sort of zooming out and looking at the the globe from the moon or whatever, you see the problem a little bit differently. And I think for our next generation of challenges, going up the big science sort of questions, it would help us to be coordinating much more in the region as well. And Australia has a leadership role, and we're the only one really in the south of the equator doing all of this stuff. And we could be actually a thought leader, you know, in this space as well. And a driver of the collaboration, not just sort of waiting for things to happen.
Thanks, Ben. Dietmar.
Yeah, I'd like to, I'm Dietmar Müller, Sydney Uni and ARSCORP. And so I want to briefly bring the discussion back to the academy itself, right, and the role that it might need to play in this leadership role. Right? So the academy, as it turns out, is pretty much an agglomeration of silos itself. Right? Have a look at their webpage and look at all the different national committees for science that exist that all develop their own decadal plans. And if you're lucky, they might have an observer from another group on their own committees, but I think generally there's not a hell of a lot of communication. And looking at those groups, you will notice that there's a National Committee for Earth Science and also a National Committee for Earth System Science, and the two are apparently very different things, right? And I think that is at best a questionable distinction, right? And because as it turns out, the Earth system is just the ocean and the atmosphere, and the rest of it is not part of the Earth system, right? Now, and there's also a National Committee for Geography, and there's another one for Ecology, and there's a separate one for Antarctica as well, right? And so on the one hand, I understand that the science that we're all doing is quite different and needs to be managed at a more fine-grained level too, right? But we are actually lacking a vehicle at the academy level, right? To perhaps think about developing a decadal plan for the Earth, for Earth science, and in the context that we have been talking about here, right? And I think the academy, and I mean, I'm part of the academy as well, but yeah, also I bear some responsibility there too, you know. But is Malcolm in the room still?
He's hiding up the top.
He's hiding up the top, yeah. So I think the academy also bears some responsibility to think about, you know, how they can pull all this expertise together into an overarching plan that can lead the sort of data or guide this data integration that we are talking about here. And why are we doing it, as Ben and Andy just talked about, right?
Fantastic point, Dietmar. Thank you so much. There were two other hands up earlier. Was there another one? Just okay, and Donald, and then we're going to stop, I think. So I'll take a microphone to one of them.
First.
Thank you. Thank you. My question's probably weirdly specific, but I'm a very heavy user of Nectar and a light user of NCI. And when I go to NCI, I have a lovely persistent home folder that keeps my stuff forever. But when I collaborate with people on Nectar, I kind of have to do all that myself. There's no, like, a national federated home folder for everybody, and everybody that we work with overseas would be amazing. And I might just be missing something in how I'm using the tech, so I'm excited to talk to the panel as well.
I'm going to take that as a comment that maybe can be discussed over lunch or in the session afterwards, and I'm going to take Donald's as the last comment of the day.
I'll keep this really brief. It would have been a terribly long discussion if we'd got into it. I was interested in asking the panel, but we can talk about this afternoon perhaps. Is it sensible for us as we go forward to be continuing to do as much as we do of this stuff inside each of our individual NRIs? Or for sustainability, scalability, overall carbon budget, do we need to have a professional research infrastructure that handles a lot of this stuff on our behalf and provides excellent services to the others? And I don't know what that would look like. I'm just thinking that we've got a lot of challenges that are very similar, and yet we still very easily stumble into being siloed in how we solve them.
Great point, Donald, and great question for us to consider after lunch. We've just got Mark, who's with our online people.
Online, yeah, one online question around industry engagement. So what should we do to encourage the uptake of open and efficient data formats by industry when major stakeholders and software vendors are wedded to proprietary formats?
Another one that I'll take as a comment that we can maybe consider in the session after lunch. So I will call it to an end. We're going to have lunch now. After lunch, we're going to do some breakout sessions, but we will come in here first and we'll get a pep talk and then some advice on how we're going to do that.